Hello, my name is Michiel van Haarlem. I'm head of the SKA office at Astron, the Netherlands Institute for Radio Astronomy, and chair of the SKA Regional Centres Steering Committee. I'd like to thank the organizers for giving me the opportunity to tell you about plans for the development of the network of SKA Regional Centres that will play a critical role in providing the users with access to the data obtained by the two SKA telescopes, SKA Low in Australia and SKA Mid in South Africa. As you've already heard on previous days at this meeting, the data volumes produced by both SKA telescopes are enormous and therefore require a considerable amount of preparation and planning. Current estimates indicate that of order 700 petabytes per year of original observatory data produced by the SKA science data processors will need to be distributed to a global network of regional centers. The data coming out of the STPs in Cape Town and Perth will be transported over a network of fibers. That network will also take care of some of the data transport between the individual regional centers. It's important to recognize that SRCs are a critical part of SKA science operations because users will only be able to access, process and analyze their SKA data in the SRC network. There will be no access to the SDP processing facilities for users. Also, the SRCs will host the long-term SKA science archive and therefore provide a lasting legacy of the telescope and its results. SRCs can also play an important role, especially in the construction phase, by giving users early access to data and build support for the SKA processing approach, which requires that standard data products are produced on pipelines that are created as part of the SKA construction program. Collaboration between SKAO at all levels on the design and implementation of the SRCNet is of course critical, because only when the SRC network is joined with the SKA telescope do we have a full end-to-end capability. The assumption at the moment is that each SKA member will have an SRC node, although there are investigations going on whether it might not be better or simpler for some smaller members in particular to join forces to set up an SRC node together. It's also important to realize that the contributions to the SRCs will differ from country to country. Each country has its own existing infrastructure and infrastructure providers that will hopefully contribute to the SRCNet. Those multiple resource providers may be funded through different sources and create a landscape that is unique to that particular country. Also, the SRCs may be part of organizations that serve multiple facilities. For example, already the SKA pathfinders and precursors, perhaps other radio telescopes or even other telescopes, or also non-astronomical research infrastructures. At the moment, SRC commitment to the development are progressing well. Most countries have some form of funding available for the development over this year and the next couple of years, but there are not many commitments yet to the long-term SRC operations phase, for example. And we're hoping that in the course of this year, we'll take a major step towards securing those commitments. Now, you may wonder, why has the SRC model been chosen? There are a number of reasons for that, some technical, but also some more political. The data volumes from the SKA telescopes are huge and significant resources are needed for visualization, analysis, and modeling. Direct delivery to users is therefore not really feasible. Also, the community of scientists working with SKA data is globally distributed in teams working on key programs or individual smaller projects, and providing those users with easy access to the distributed data is really important. Also with a clean interface and without having to worry, hopefully, about all the details of data storage and data and where the data can be processed. We're also looking to maintain a strong connection with the SKA, especially in the non-host states. This is the first time at centimeter and meter wavelengths that countries are joining forces to build a telescope that is more capable than they would be able to finance by themselves. But that also means that there's a transition taking place in the way in which radio astronomy is being organized and provided to the community. And to provide local support and continuation of the expertise is really an important focus of the SRC effort. It's also going to allow members to participate in future SKA technology developments, for example, in software, but also in hardware. And importantly, SRCs allow us to tap into relevant technologies that are of interest and of benefit to broader society. For example, high performance and high throughput computing, and gives us the potential to build up capacity and share resources with other facilities. Finally, of course, these kinds of technologies are of great importance and as technological challenges, but also societally, and therefore training and educating users and developers, for example, is a great way to build up expertise in the member countries. Here's the high-level vision that captures what we're planning to do: to develop a collaborative and federated network of SRCs distributed across the SKA members that will host the archive and provide data processing resources. Our aim is to maximize the scientific productivity and impact of the SKA, not just using original new data, but also by reusing and reprocessing archival data. We'll also support the community in using the SRC network. We'll go about it in a step-by-step way, developing an SRC network that scales up over the next 4 to 5 years as the SKA telescopes are built. But it's important, it's not just about the technical design. A lot of work will have to go into the policy aspects in order to bring all this together and to ensure that the resources that are being contributed actually function together and continue to operate in a safe and secure way. This diagram summarizes the important aspects of SRC design. Data management at the bottom is critical, distributing data from the SDP to the SRC network and keeping track of what is stored where and allowing some, but not too much, data movement between locations. Discovery of data stored in the archive in an easy and transparent way. Distributed data processing, providing processing capability and capacity where the data is stored. As I said, minimizing the amount of data movement if possible, which is both costly and time consuming. Users will often analyze, process and visualize their SKA data together with data from other telescopes, and will seek to support that. The users will also spend most of their time processing, analyzing and visualizing their data using a set of standard tools, but the science platform will of course also support user-contributed software and tools. Visualization of distributed large volumes of data, both from the SKA and from other observatories, is important and is being looked at closely. And finally, user support and training, but also disseminating and sharing the results to highlight to both the general public and to the funders the successes and the impact of the SKA and the SRC network. Here's a short history of what we've been doing over the last couple of years in developing the SRCs. It all goes back to a decision in 2015 that the SKA board at the time decided to separate SRC development from the construction program of the SKA telescopes. In the years thereafter, 2016 to 2019, there were some early explorations of the SRC concept, and the SRC's Regional Centre Steering Committee was finally set up in 2019 and is currently coordinating the activities in design and development of the SRC network. In 2020, the SRC set up some working groups to develop requirements and to explore in parallel some of the technologies and options for the SRC design. Last year, the prototyping teams were started and an architecture forum was formed. At the moment, the project has adopted the scaled agile framework approach, which is also being used in the construction of the SKA Telescope project. We're currently in the 4th program increment. These are quarterly increments which are synchronized with SKA development. This is the current focus of the prototyping teams, which may change over time, but highlights the current priorities. There's a team working on data management technologies, exploring and testing ways of moving data and keeping track of what's stored where. Another team is working on the science platform, which is the key interface to users and will also support their tools and their workflows. Authorization and authentication is extremely important in order to implement access restrictions during the proprietary period, for example, as well as ensuring overall safety and security of the network. The effort is being led by an SRCNet program team and assisted by a science working group, architecture forum, and a forum which brings together the NRENs, the network providers, academic network providers in the various countries that will be playing an important role in distributing the data and providing the network technologies. We're currently working on a roadmap that breaks down the development of the SRC network in stages that are aligned as much as possible with the SKA construction schedule and the array assemblies. This will not only support the estimates of personnel required in the safe development teams, but also the hardware resources that are needed, such as network, storage, and processing. The idea is that we try to keep up with the increasing data volumes that come out of the telescopes during construction, but don't provide those resources too early on when they're going to be underutilized. The diagram on the right gives a schematic overview of the SRCNet components, linked by color to the safe working teams on that particular part of the system. The overlay provides an illustration of the implementations that are currently under investigation or are being used. It doesn't mean that these are the final or even the only technologies, but they are the ones that we're investigating right now and seeing whether they will actually work as we scale up to the full SKA system. Here's an overview of the SKA construction project milestones, the top layer. In the middle, the different stages of science commissioning, verification, and ultimately the first shared risk observing proposals and observing cycle. And at the bottom, the corresponding milestones and releases of the SRC network, which I'll go through quickly one by one now. The first step will be to provide very basic support for AA 0.5 at the end of next year. That will be the first time that we receive SKA data, and the idea is to support early versions of data discovery of data stored in the data lake. Also basic analysis using notebooks and visualization of data. We'll also expect to have an early version of the unified authentication system up and running so we can investigate those aspects. Next step is AA1 in the first quarter of 2026 with additional functionality at all levels. And then by the end of 2026, AA2 will be complete, 64 stations for SKA Low and 64 dishes for SKA Mid, which is where things start to get really interesting and capacity starts to approach the sensitivities that are comparable, for example, with Meerkat and LOFAR. Then, towards the end of 2027 and early 2028, the plan is to move up to full capacity and capability in time for the first observing round cycle of SKA observing proposals in 2028. Our focus for the rest of this year, in parallel with the ongoing prototyping and development effort, is to document our plans and have them be reviewed by an external panel in the third quarter of this year. This will then hopefully form the basis for a discussion in the SKA Council later this year, where decisions on SRC governance and funding will hopefully be taken, essentially giving the green light to continue to develop the implementation of our plans. That concludes my presentation. If you'd like to have further information, then please contact me at the email address indicated here, or talk to some of the SRC members that are currently attending the conference. Séverin Godet from Canada, Karen Lee Waddell from Australia, Hyung-Woo Kang from South Korea, and Takuya Akahori from Japan are at the meeting. Also, you can approach Shari Breen from SKAO and talk to her about SKA Regional Centre developments, or Joe Callingham from Astron, who's closely involved with SRC development in the Netherlands. Thank you very much.
Okay, any questions? First we'll go to the audience. Very back here.
Thank you for the talk. So I was wondering if you could say a little bit more about, for all the different capabilities, who decides what the SRCs, the individual SRCs do in the final SRC model? Is that kind of top-down decision from, say, the council, or is it more, let's say, democratic between the SRCs themselves?
I mean, the question, I don't really know where you want to go, but if the idea is that all functionality will be available to the user, so the division of responsibilities depends really on the data, where the data is stored. So the data is stored, and a particular bit of data goes to a particular site, but the functionality that's provided is independent of that. So
I guess I was more thinking, so say you have these tasks of data processing versus, say, a help desk, and you have different SRCs around the world, and is it that they're all providing that capability at the individual SRCs, or is it, you divide that responsibility up among the network? And if it's the second one, who decides which SRCs do what?
Yeah, okay, there might be some degree of specialization, and that will be done in collaboration. The SRCs will get together, they will have a network, and they'll decide among themselves how they distribute those responsibilities. I agree that it may not be viable for every node to provide the same functionality or to provide the same depth of knowledge, for example, to users. So that will be decided among them. Yeah.
Okay, we have an online question.
Hi, yeah, this question is from Ilse van Bemmel. Will each SRC have access to all data? If not, how will users identify which SRC to use?
Now, the idea is that the users will not need to care about where the data is being stored. The SRC network will take care of that on their behalf, and so they will interact through a web interface or something like that, and start up their processing jobs, and the infrastructure that we're developing will actually take care of finding the data and allowing it to be processed.
Okay. One final question.
Yeah, so what are the lessons learned from ALMA? Are they useful, and are we keeping track of that, especially in Europe, where they created a whole bunch of nodes that did do some specializations? I think that it might be very worthwhile. I know it's a different telescope and everything, but worthwhile to keep an eye on that.
Well, we're definitely in touch. I can't give you a detailed answer to your question about what lessons we've learned, but we're definitely in touch with the ALMA Regional Centre networks in the various countries that are involved in SRC development. And so trying to learn from them and take the lessons is definitely one of the things that we're doing.
Okay. Go ahead.
Yeah, and in some countries, the people from involved in the ALMA Regional Centre network are actually actively involved in developing the ideas for the SRCs.
Okay, great. So let's thank Michiel again for that talk.